You have to understand what do you mean by mass to number of particles. Okay. Now let us look at this one. Chemical equation. The following chemical equation is given. Ammonia is produced. So nitrogen plus hydrogen gives us ammonia. Is it balanced here? Is it balanced chemical equation in my case? No, let us balance here. We have N2. Here we have only one N. So you have to put 2 here. So 2 and 2 times 3. 6. We have only 2 here. So we have to put 3 here. Now here remember there is 1. So these are called stoichiometric number. The number you put in the front. Now this will tell you. Now for example, if you are to produce 2 means now here 2 moles. This number, stoichiometric number represents moles. So in order to produce 2 moles of ammonia, how many moles of nitrogen do we need? 1 mole. How many moles of hydrogen do we need? 3 moles. But in our case, they are saying calculate the number of ammonia molecules. So we have ammonia here. Instead of moles, they are saying how many molecules. Moles and molecules, are they similar? Are they similar? Moles is a unit. Molecules, when atoms combine together, they form molecules. Right? Just like atoms, molecules, ions, like I said, they are particles. Moles is a unit. Which means if you have 1 mole, how many molecules of ammonia will you have?
Avogadro's number.
Avogadro's number. So which means 2 moles means how many ammonia molecules are produced in this chemical equation. 2 moles means 2 into
Avogadro's number.
Avogadro's number of now moles. Is it moles? Huh? We are converted 2 moles to molecules of ammonia. So 1 mole means Avogadro's number. You have 2 moles. 2 into Avogadro's number. This many molecules of ammonia has been produced here. Okay. Now they are saying you have 14 grams of nitrogen. So the relationship is between nitrogen and ammonia. Do we have to consider this hydrogen here? No. So imagine this is not there. But we know if you have 1 mole of nitrogen, we will get this many molecules of ammonia because 2 moles we have converted to in terms of molecules. Alright. Now 1 mole of nitrogen produces this many molecules of ammonia. But is the question asking, are they saying 14 moles of, if you have 14 moles of ammonia, how many molecules are you producing? Now then you can take like this. Because here is mole, here is also mole. The 2 units are same. Right? But in our case, what is given instead of moles? Grams. So here we have moles. So what can you do? You have to convert these moles of nitrogen to grams. So 1 mole of nitrogen in terms of weight, how much is it?
28.
It is equals to is gram molecular mass. The molecular mass 2 into 14, 28 grams of nitrogen, meaning it is 1 mole of nitrogen. Yes, but we don't need moles here. Question is asking mass. So mass to number of particles. See, molecules is particles, right? So mass to particles, mass to, now they are asking how much particles is it? This unit should be same. Meaning here molecule X means you're also finding molecules of ammonia. If you take here mole, if you write down mass below, are the units same? You have to bring this to same unit. That's why we have converted 1 mole of nitrogen to mass. Question, mass is given. So you have to convert this to mass, bring it into same unit of nitrogen. Are you getting it? So this is called mass to particles relationship. So how much ammonia molecules will be produced if you have only 14 grams? Yes, see here, 28, it is halved, right? Meaning half of this will be Avogadro's number of molecules. Logic? Are you getting it? Even without calculating, you can do this. So if you take 14 grams of nitrogen, you are producing Avogadro's number of ammonia molecules. Meaning you are producing only 1 mole of ammonia if you start with 14 grams. Yes or no?
Yes,
Because 1 mole is Avogadro's number of molecules. You got Avogadro's number of molecules. If they ask you how many moles of ammonia will be produced, it is 1 mole. But right now, that is when you take 14 grams of nitrogen, my dear. Okay? 14 grams of nitrogen, you will get 1 mole of ammonia. But the question is now asking how many moles. They are asking how many molecules. So you got Avogadro's number, meaning you are producing 1 mole of ammonia. Yes? Okay, so this is the last relationship, the calculation. I hope it will get more clear as and when you practice more questions. It gets better. Okay? Yes. The last part of the calculation now. How many atoms of oxygen are present in 300 grams of calcium carbonate? So here there is no chemical equation, okay? So there are lots of these questions in that mole paper I asked you to download and then solve. Remember? Okay, can you see this? This one. The molar mass of CO2 is 44.01 grams per mole. What does that mean now? This one is important. If you understand this, that calculation is easy. Now let's see here. The molar mass of CO2. You know CO2, the molar mass is 44, but here they have taken carbon as 12.01. That was the actual, but in your case you can use round off. So here you can also say 44 grams, right? So the molar mass of carbon dioxide is 44 grams per mole, or in our case 44.01. Okay, what does that mean now? 1 mole of CO2 has a mass of 44.01 grams. Yes? The unit for molar mass is 44 grams per mole. Meaning, to get 1 mole of CO2, what is the weight? 44 grams. So 44 grams of CO2 is equals to 1 mole. That is the unit of molar mass. That is the understanding. If you want to take 1 mole of the substance, what is the mass you need to take? That is the unit for molar mass. Like the molar mass of nitrogen we saw earlier is 28 grams per mole. The grams per mole is the unit for molar mass. Meaning to get 1 mole of nitrogen, how much weight of nitrogen do we need to take? 28 grams. That is the meaning of first one. Now the second they are saying, there are Avogadro's number of molecules of carbon dioxide in a sample with a mass of 44 grams. Meaning now see here, in that 44 grams of CO2, if you are to count the CO2 molecules, how many CO2 molecules will be there? Avogadro's number. Why? Because 44 grams is 1 mole. In 1 mole there will be Avogadro's number of molecules. You understood that third one? Yes? Meaning N2, 28 grams is 1 mole. So in that 28 grams of nitrogen, how many molecules of nitrogen will be present?
6 Avogadro's
Avogadro's number, 6.023 times 10 to the power 23, because 28 grams of nitrogen is equals to 1 mole. In 1 mole, we have Avogadro's number of molecules. Only the mass is different. See here, 44 grams, here it is 28. But in both the case, we are taking 1 mole. So, in that mass, this many Avogadro's number is there for CO2. But if it is nitrogen, it is 28 grams, not 44. Different elements will have different mass, different substances. Okay. Now, the fourth one. In 44 grams of CO2, there is 1 mole of carbon and 2 moles of oxygen. How did we get that? So in that 44 grams of CO2, how many moles of carbon is there? 1 mole of carbon, and then how many moles of nitrogen? 2 moles. So that you get from its formula. See here. CO2. How many carbons are here? How many oxygens are here? So this number we are taking as mole. So there is 1 mole of carbon and how many moles of oxygen here? 2. This subscripts we are taking as moles. So 2 moles of oxygen. So total how many moles are there? 2 plus 1? 3 moles are there in that. So 1 mole means what is the mass? 44 grams of CO2. So we are saying in that 1 mole of CO2, you have 1 mole of carbon and 2 moles of oxygen. Now, for example, if it is ammonia, in that 1 mole of ammonia, which means this is 17 grams, right? Ammonia is 17, nitrogen 14 plus 3, 17. How many moles of nitrogen is here?
1.
Yes, we have 1 mole of nitrogen. And how many moles of hydrogen are here?
3 moles.
Yes, we have 3 moles of hydrogen in that 17 grams of ammonia. Because 17 grams of ammonia is equals to 1 mole of ammonia. Are you getting it? Yes? What about our water molecule H2O? H2O is 18 grams. So in that 18 grams of water, how many moles of hydrogen atoms are there? 2 moles of hydrogen atoms. How many moles of oxygen atoms are there?
1.
1 mole of oxygen atoms. Now, let us come back to this 44 grams. So here, we know there is 1 mole of carbon atoms, and then there is 2 moles of oxygen atoms. It's not molecule, these are atoms, but there is 1 mole of that. Okay. Now in that 44 grams, if I ask you how many total atoms or particles are there, how will you do it? So there is 1 mole of carbon atoms, meaning in terms of particles, how many carbon particles are taken there, atoms? Yes, because 1 mole of carbon atom means in terms of atoms it is, so which means there is 10 to the power 23 carbon atoms, and how many oxygen atoms are there now?
2 times 2.
Times 2, yes, plus 2 into Avogadro's number of oxygen atoms. So meaning this total number of atoms are there in 44 grams of CO2. Did you get it? Where is it now? What happened? Okay. Let's come back. See here. 44 grams of carbon dioxide, there is a total of 3 moles, 2 plus 1, 3 moles. Alright? So in 44 grams of carbon dioxide, 32 grams of this is due to oxygen atoms. 2 into 16? 32. So out of 44, 32 is oxygen, rest will be carbon. 12 grams will be because of carbon, 32 grams will be because of oxygen. That's why it is 44. Okay? Did you understand this? So meaning there is 3 moles total, right? So can you do 3 into Avogadro's number? What is the total number of particles present in that 44 grams of CO2? So because 2 plus 1 is 3 moles, right? So 3 into Avogadro's number?
1.8.
1.8069 times 24 total atoms are there here in that 44 grams. Now we did it this way. Can you do this and then see whether we get the same answer? Avogadro's number plus 2 into Avogadro's number. Do we get the same answer? Yes? So she's nodding yes. Your name is unique. Tenpei. Yes. Tenpei. Tenpei is nodding. She has already calculated. So do we get the same answer? Because there is total 3 moles of particles there, right? So which means 1 mole is because of carbon atom, 2 moles is because of oxygen. So if you check these particles, you will get the same answer here. 3 moles. 3 into Avogadro's. Did you get it now? Now we will come back to that question. Now it will be how many atoms of oxygen are present in 300 grams of calcium carbonate, CaCO3. They are asking how many atoms of oxygen. See here we have calcium carbonate here. Okay. Now if we had 1 mole of calcium carbonate, in that 1 mole of calcium carbonate, how many moles of calcium are there?
40.
How many moles?
1 mole.
1 mole of calcium. We have 1 mole of calcium plus how many moles of carbon?
1.
1 mole of carbon. Carbon atoms, okay, by the way, this is calcium is also atoms. And how many moles of oxygen atoms? We have 3 moles of oxygen atoms in that 1 mole. Alright, now right now they are given mass. 300 grams of calcium carbonate. So 1 mole of calcium carbonate in terms of mass, how much is it? Mass, not Avogadro's number. Talking about mass, molar mass. Gram molar mass. Calcium carbonate. Calcium 1, carbon 1, oxygen 3.
100.
Sorry?
100.
Yes. So which means in that 100 grams of calcium carbonate, now they are asking how many oxygen atoms are here. Right now, this one is in moles. We have 3 moles of oxygen atom in that 1 mole of calcium carbonate, meaning 1 mole of calcium carbonate means how much? 100 grams. In 100 grams of calcium carbonate, there is 2 moles of oxygen atom. We got it from the formula, right? But if they are they asking moles? They are asking atoms. So 3 moles of oxygen atom in terms of atom, in that 3 moles, how many oxygen atoms will be there? 1 mole means how many oxygen atoms will be there? Avogadro's number, we have 3 moles. So 3 into Avogadro's number of oxygen atoms are present in 1 mole, meaning this is a mass. So 100 grams means 1 mole. The reason I changed this to mass is because mass is given there. Instead of 100, we have 300 grams of calcium carbonate. So how much oxygen atoms are present here? More than the answer, you have to know what is happening here. This might be a little bit complicated, but if you practice that mole paper last year, there's full of questions based on this, right?
Yes.
Go through it again. So what is your answer?
5.2410.
Yeah, look at this one, what we did here. O3, 3 moles. So that many oxygen atoms are present more in that 100 grams. Yes, so we have 300 grams. So how many atoms of oxygen are there? What do we get? 5.4207 times 10 to the power 24 oxygen atoms are now present in 300 grams of calcium carbonate. This is your task now. Calculate the total number of atoms present in 196 grams of sulfuric acid, H2SO4.